Network Address Translation, NAT, converts private local area network, LAN, IP addresses into public IP addresses so they can communicate with devices outside the LAN. It may sound complicated, but just like an administrative assistant keeps business flowing, NAT gets the job done. Well, in this episode of Cisco Tech Talk, I'll explain Network Address Translation, NAT. Today, I'd like to compare NAT to an outstanding administrative assistant. I'll call him Nate. The office where Nate works is its own little community. Everyone in the building can share resources and communicate with each other quickly and efficiently. They don't need Nate to interact with each other. But when communication needs to go outside the office, that's when Nate gets busy. He handles all incoming and outgoing messages. If an employee wants to send a letter to someone outside the office, Nate replaces the employee's name and office number with the building address and a unique identifier. He keeps track of the correspondence by creating a record. It maps the unique identifier to the original employee and their office number. When a response arrives at the office building, he looks up the unique identifier, retrieves the corresponding employee's details, and delivers the response to the appropriate office. Similarly, in a network using NAT, when a device from the private network wants to communicate with the internet, the NAT device assigns a unique identifier, port number, to the outgoing message, replacing the private IP address of the device with the public IP address of the NAT device. The NAT device keeps track of these translations in a table. When a response arrives from the internet, the NAT device refers to the table and replaces the public IP address with the private IP address of the intended recipient. It then forwards the response to the correct device in the private network. So, just like Nate manages the communications for his office building, NAT manages the flow of messages between devices in a private network with the internet. Now, you may be wondering why all this translating needs to be done. Why not just give every device a public IP address? To explain this, I'll go all the way back to the late 1980s. Every device that connected to the internet used Internet Protocol version 4. When created, IPv4 had over 4 billion unique public addresses available, which sounds like plenty, but it wasn't enough. The pool of public addresses wasn't going to last, and a new plan was needed. By the early 90s, NAT was created as a temporary solution. A permanent solution was created in the late 1990s, IP version 6. IPv6 provides an additional 340 unidecillion unique IP addresses. Never heard of a number that big? Me neither. Now there are plenty of addresses available, but many places still use NAT. A big reason is for security and privacy. NAT acts as a barrier between the internet and the devices within a private network. It hides the internal IP addresses of devices, making them inaccessible from the outside network. This provides a layer of security by preventing direct communication with internal devices and helps protect them from certain types of attacks. NAT also simplifies network design by allowing organizations to use private IP addresses internally. This saves money, as well as the hassle of managing a large number of public IP addresses. NAT can assist the transition from IPv4 to IPv6 by providing IPv6 connectivity for IPv4 devices. This technique, known as NAT64 or IPv6 to IPv4 translation, enables IPv6 only networks to communicate with IPv4 networks. Wow, NAT really plays a crucial role in optimizing IP address usage, enhancing security, enabling connectivity, and facilitating the transition to newer network protocols. Just like Nate, NAT is invaluable. Thanks for watching. I'll see you next time.